Welcome to the IMSAI channel, where I try to resurrect an old IMSAI 8080 computer. Okay, I've discovered a low battery indicator. I didn't even notice that the first time I looked at this thing, kind of hidden under this knob. So if I turn on the oscilloscope, and I have a power supply connected where the battery should be. And right now I'm running at about 8.3 volts, which is pretty nominal for a fully charged battery. And if I start turning down the voltage, 7 volts, 6.8. Oh, there we go. You can see the indicator's flashing now. So let's see where. Yeah, it's at 6.9. Oh, 6.9. It's just starting to flat. There it goes. So right around 6.9 volts, the low battery indicator starts to go. So that's great. The other thing I noticed, I don't think I did the calculation for battery life correct last time. So here we're at about an average battery voltage around 8.2. We're at 0.38 amps, so 380 milliamps. And as the battery starts to get discharged, that's going to go up to about 0.4. So let's say on average it's about 0.4. And let me grab my calculator. If we have a 3000 milliamp hour battery and we're drawing 400 milliamps, then we should expect 7.5 hours of battery life. So yeah, but 7.5 is fun. The other observation I had was with this schematic. You can see that it called out some NiCad cells here that were 1800 milliamp hours, 1.8 amp hours. And we remember when we measured the current that was being sent, there's a potentiometer that sets the charge rate. We had measured it at, I think it was 178 milliamps. And it says here these are rated at 1.8 amp hour, so 1800. So they had it set to exactly 1/10 of the charge capability of the cells. So that makes a whole lot of sense. This thing was 1800. They had it set to 1.8. 0.18. Yeah, so when we get the new batteries, put them in here, they'll be 3 amp hour batteries, and we'll change the potentiometer to give us 300 milliamps, and that'll be the correct charge current for the new cells. I found one other error on this oscilloscope, and that was I showed you these before, these pull switches, and this particular switch was bad. It wasn't working. So I'm sorry I didn't film it, but I took that switch out of there and found a little switch in my junk box that seemed to fit in there with some fiddling. So anyway, I replaced that, and so still waiting for the batteries. Caution, lithium-ion battery. I don't think it is a lithium-ion battery, but nonetheless, let's be careful. Probably don't want to cut into it aggressively. Let's see what we've got here. Yeah, there we go. So nice little in focus. I don't know if it's in focus or not. There we go. Tenergy, 3000 milliamp hour. These are sub C, so these will fit nicely, and they come with tabs on them, which allows you to build up your own battery pack. So we will take that out the garage, build up a battery pack, and get our little oscilloscope running. Alright, let's see what these are going to look like. Take the heat shrink off of them. Have to be careful with these. Don't want to be shorting things out, causing sparks and fires. we go. Just a tab. Maybe I'll leave that other one on. So you got to make sure you build these the right way. Okay. So plus minus, minus plus. Let's see what the best way to do this is. I could build them off to the side, but then it might not fit. Or I could bend one over, have one go over and one go under. That's probably the way to do it. Do an over-under. Yeah. Over-under, solder those together, and rinse and repeat. Good. So, let's see, where's the old battery pack? Okay. Oh, I think I threw it away. But it, the way that it's constructed is you had 3 in a line, and then a 3 in a line, and then another 3 in a line, and then they were together. So look from the top here. They were in line like this. So let me solder those together, and then we'll have to figure out how we're going to protect them from shorting out to other things. I have some something I think we can put on there. Yeah, I think this will be good. Let's see. Yeah, a little vise to hold things. I'm brave using a steel vise, but whatever. Okay, just to hold them together while I do the soldering. I could use a one with plastic jaws, might be smarter. I'll do this one on camera and do the other ones off camera. Yeah, okay. Let's see if we're still doing here. We'll turn on the soldering iron. Oops, no, let me put in a big tip. I have this Metcal soldering iron, and it has removable tips. So these tips come in various shapes and temperatures and stuff, and these are very interesting soldering irons. This soldering iron is nothing but a coax cable, and RF frequency, radio frequency, comes into this at a high power, and this is the terminating load to the RF amplifier over there. And there's actually a coax connector on each of these, and you can just pop them in and out very easily. And I have this one I've never used before, but it's a very wide tip, and it should be very hot. So it's made just for stuff like this. So let's give that a try. Turn the timer on. I have it on a 30-minute timer in case I forget to turn it off. I don't burn things down. And for this kind of stuff, I like to use soldering flux. Here's the box here. Soldering flux. And I should not cut myself. This is just tree sap, believe it or not, just pine pitch. And it just helps. I'll put a little goo in between here. A little on the top, a little on the bottom. Okay. And I like to use leaded solder. This is Kester 44. Let's see how we're doing here. Soldering iron. Took it well. Took the top well. Okay, so now I'm going to push these together, and I don't want a big thermal mass. I'll just use a sharp point, and we'll be able to solder these together. That did it. Yep, very good. Very solid, very nice. Okay, I will continue and I'll come back when I have it all together. Okay, there we go. Put some Kapton tape to hold it together, and I have all of the tabs soldered together very nicely. I have the two tabs here, plus and minus, and can measure their voltage here. So currently it's 7.7 volts, and I think what we want to do is we want to charge these up and get them around, get them over 8 volts, and then we'll put them inside the oscilloscope and adjust the current there, and yeah, that's pretty good. So I think we'll use the power supply over here to charge things up, so let's get that set up. Okay, we have a triple supply here, 0 to 6 volts and plus or minus 25 volts, so we'll use the plus 25, the yellow one. So plus 25 we will set to, let's say 8 point, I don't want to go above 8.2 right now. And I will set the current limit to 300 milliamps. And let me hook it up. Let's see, ground and yellow. So ground goes to ground, yellow goes to yellow, and we can supply limits and output on. So if I disconnect it, go up to 8.2, and at 300 milliamp we're at constant current mode, or at 7.85. So we should be able to watch that number go up, and it should stop at 8.2. There we go. It's going up. I saw 8.6. All right, so I'll be back in a while. I don't know if I was in focus there, but still getting used to videotaping. But it's going up 8.7. So we'll just have to let it sit here, and should be ready to go. I'll find something to insulate these with. All right, let's put the cap on this stuff. We're going to use some really weird material. I've always called it fish paper. I have no idea what this stuff is made of. It's really hard, and it's kind of rubbery, plasticky, but not. It's, I don't know, it's like rubber impregnated fiberglass. It's very weird stuff. So anyway, I've seen battery packs that's made this way before, where we're just going to take the outline of the draw around the batteries. We'll take the outline of the batteries and make a little cutout for the top and the bottom, and then use the Kapton tape to put it all together. I've seen that done before in other battery packs, and it seems like a good idea, so that's what we'll do. Okay, have the batteries all packaged up here with the fish tape on the top and bottom. So Got the two tabs sticking out, and I guess I need to label them. This is the plus one. I can see it on the batteries. That's the minus one. And can pan up here, take a look at the power supply. It's right at about 7.93 volts. So let it finish off and put it in. Okay, I got the wire soldered on, heat shrinks. Figure out how to tidy it up in here. So I got the right size batteries for sure. Okay, so I got the perfect fit. Alright, so we've got a couple things going on. We've got another piece of foam, which I don't know if we're going to need now. So it goes there. And then we have the top. I guess the other foam's good. There we go. And screws. Wow, here are the screws. And screwdriver. Alright, so let's give this a try. Alright, let's see how we're doing here. That goes there, make sure there's no shorts. Everything's looking pretty good. Oh, we forgot our foam on the bottom. Let's go ahead and put that in. Keep it original. There we go. All right. Did it again. Got the top one this time. Good. Okay. This time for sure. Looks great. Alright. See what other screws we need here. There's one long one. I'm not sure what that one long one is. Might be for this. Put on all the short ones first. These are supposed to be short over here. Yeah, I think the long one goes here. So not, oops, it's magnetic. It's in a piece of plastic, so the more threads the better, I think. Although it's not. No. Not sure. I'll go with a short one then. Straight. There we go. Oh, straight. Okay. I've got some screws left over. I wonder where they were. Huh. Maybe they were from something else. This looks like it's ready to go. Let me try to focus on that. Let's see. I think you can see that. There's a switch here that's in up position. It's AC input full charge. In the middle it's trickle charge. So when you're in full charge, it'll be putting in the full amount of current. Trickle charge just to keep the battery topped off, and then the bottom you go to the external DC. So put that in. Whoa, it's rugged. Okay. I don't see any reason why we can't plug it in. We could test it. Yeah, we could test it. Oh. So the power comes off these three connectors here, and we can check these two. We've got 7.8 volts. All right, that's good. Let's put this away. I got the oscilloscope and pop it together. This is the little latch that holds it all in, and these are the power that needs to go on. Weird thing is that black is positive and white is negative. I hate that. And then it's got a ground pin here for safety. Alright. And if I turn it around and turn it on, does it go? No, it doesn't go. Oh, yeah, it did. I saw it flicker for a second. I don't have any input, I think. I saw it flicker again. Maybe it's just not charged up. I'll get you resituated here. Let's put the AC cord in. See what happens. Let me measure some voltages. .8, which is right. And let's see. I don't know. What am I doing wrong? Oh, there it is. That's what it is. It was off screen. Yay! I don't know why we're wiggly. Why are we wiggly? And maybe because we're in charge mode? Let me unplug the AC. Ah, that's what it is. It's the AC. That's wiggly. So now we're operating on batteries. So I guess when you're charging this thing, there's enough AC ripple in the system that it comes through. So probably best to charge it and then just use it off of batteries. And horizontal works. Horizontal expand works. Vertical expand now works. The vertical expand didn't work before. Now it does. That's that switch that I replaced. So vertical position works. Awesome. Works on batteries now. I'll let it charge up. See if it lasts 7 hours. Very cool. Put the case back on and go show my friends. Okay, I almost forgot. We need to adjust the current. And so this is the 0.3 ohm resistor. So I'll put a voltmeter across that. And we're measuring 35 millivolts. Okay? So get out a calculator. And if we have, let's see, if we have 35 millivolts and we have 0.3 ohms, then we're outputting 120 milliamps, 116 milliamps. And this is the adjustment right there. So let me get an adjuster here. All right. So we want 300 milliamps and 0.3 ohms and 0.3 amps is 90 millivolts. So I am going to adjust this until it says 90. Where's the slot? There it is. 40, 50, 60. It only goes to 60. Guess I can't adjust it very far. 62 is all I can get. 62 millivolts. Oops. And 0.3 ohms is 200 milliamps. So we'll have to charge at 200 milliamps. Oh well. Good enough. 200 milliamps is safe. And it works. So I'll leave it at that. Okay, I got too excited. I forgot. There's these plates. These plates go in and protect the battery on both sides. So, oh no! I think I have to take this top plate off again to do it all. So, anyway, I'll put those on and button it back up again. All right, I thought it wasn't working, but I'd accidentally touched the intensity knob, and it looked like it was off, but actually it was just the intensity was just rolled down. We can get a nice picture on the scope now. There's a focus knob here. Oops. There's a focus knob here. Whoa! I guess those don't work very well. And my wire fell out. There we go. Okay. I think that's all for this oscilloscope. It works fine. Maybe we'll use it testing the IMSAI. Sorry about the diversion, but I found it at the flea market and just couldn't wait. So I thought you guys would get a big kick out of it too. I don't think many people have seen this. I certainly haven't. I checked the price list, and these were $1,200 in 1976. They made these up to about 1978, I think. So they were really high end, high end at the time. This one was rated at least 10 megahertz. I put a function generator on it, and I've tested it to 15 megahertz. So Tektronix was always very, very conservative with their numbers. So yeah, good 15 megahertz little portable battery-powered scope. Very cool.